Not see it yet.
The universe is calling you. The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. Fields and forms, math and voids. It all sings with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in
And hello everybody, welcome to SkyTour Livestream. I'm Mark D'Antonio here with you, and as always, as you can expect, I also have Daryl with me tonight. Hey Daryl, how's it going?
Hello, Mark. I'm well, thank you. Hello, everybody.
That's good, Daryl. I'm glad that you're doing fine out there in Colorado.
Yeah.
I figured we'd have a stream tonight, just to check things out.
Yeah. Supposed to get a break from the heat tomorrow, high only in the 70s.
Oh, wow.
And then back to the 80s and surely back to the 90s again.
Mm-hmm. Yeah.
But cooler tomorrow and better chance for rain.
Yeah, for sure.
Moisture as usual.
Mm-hmm. Well, folks, I'm figuring tonight we have a couple things to look at. We have a comet that is now in Leo, out of Virgo. That's comet C2023 Tsuchinshan Atlas, which is going to be getting brighter and brighter as it gets closer to us. And then we're going to have a look at the star T Corona Borealis, which is going to be the star that will be going nova later this year or possibly before then. So I want to be right on top of that. I looked at it last night real quick. It was really windy out there, but I risked it anyway. I didn't take any pictures of it. I just made sure that it had not gone nova. It's not going supernova. It's going to go nova. A star that goes nova is a star that is going to do it over and over again. It's a recurring thing, and the reason this happens has to do with what's going on in the core of the star. The core of the star is a certain mass. There's a magic number beyond which any additional mass that falls on that star from a companion star could cause that star to explode and go absolutely, into a nova, supernova. And that's not going to happen with this particular star. That won't happen with the sun. It'll happen with any star that may have a mass that starts to exceed 1.44 solar masses. That's called the Chandrasekhar limit. And Subramanian Chandrasekhar discovered this value. And what happens is if a white dwarf that is the end state of a normal star, kind of like the sun, they go into a red giant and they shrink down and they shrink into a white dwarf. And that's as far as they go if they're a certain mass. Beyond that mass, they can shrink further into a neutron star. And if even more mass, they can shrink further than that into a black hole. So you have white dwarf, neutron star, black hole in that order. So if you have two stars orbiting each other, and one's a red giant, one's a white dwarf, so the one star went through its life cycle and has shrunk down to a white dwarf, then you can have that red giant swell up when it starts to end its life and start feeding. Okay, start feeding gas through their common center of rotation onto the surface of the white dwarf. And
Speaking of
what?
Gas.
Oh, okay, yeah. And so the white dwarf will now acquire mass from the red giant. And what can happen is if that mass reaches a certain level, certain density, and a certain temperature, if the total mass of that new gas on the surface of the white dwarf plus the original mass of the white dwarf does not exceed that magic 1.44 solar masses we talked about, then it's possible for that gas on the surface of this white dwarf to spontaneously start to fuse. And this runaway fusion can occur over a couple of days. And what will happen is the star will brighten tremendously. And because the mass of the star did not exceed that Chandrasekhar limit, the star will burn off this hydrogen in this bright blaze for a short period of time and then go back to being a white dwarf like before and start the cycle all over again. This particular star does this every 80 years or so. And we're right on that time frame right now. So it looks like we have a chance of seeing this this particular nova that will occur. So pretty neat. All right. Now, if the mass did exceed the 1.44 solar masses, as does happen with other stars, then the white dwarf is destroyed in a supernova explosion, because that 1.44 solar masses is much more mass than the white dwarf can sustain and hold itself up, because the gravity is trying to crush it, and the gravity will win if it reaches that magic number. And when that happens, the star will be what we call disrupted, and so it will explode in a massive explosion we call a type 1a supernova. And this is one of our cosmic distance candles. We can use these particular supernovae to figure out how far away things are, because they have remarkably the same intrinsic brightness when they go off. So we compare the apparent brightness that it may appear in a galaxy far, far away, and we know how the intrinsic brightness is supposed to be. So knowing the difference between the apparent brightness and that intrinsic brightness, we can figure out how far away it is, because we get something called the distance modulus. So there, you just had the first 2 weeks of an astronomy class in about 3 minutes 40 seconds. Daryl, if you want to add to that, feel free.
I think you pretty much covered it, Mark.
All right. Well, this is Measure 13 we have right here, and this is just a straight 1 second shot. And now that it's gotten darker, we'll just do a 12-second shot of Measure 13, the globular cluster, known as a halo object. They orbit the galaxy, which is really cool. And I'm going to start a live stack as well. That is not a supernova. That is just a previous look. Okay, and then we're going to come over here, and we're going to get our... Here we go. So I'm going to line up our curves, get the red, the green, and the blue curve lined up with each other. That's called color balance. There we go. And then I will now use a processing to show us a little bit. That's a little too bright. I'll knock that off. I'll show us some processing of Measure 13, this globular cluster. And there we go. This halo of red you see around it, that's because we still have the sunset light out there in Arizona. I'm in Connecticut, and the observatory is 2,600 miles away from here, out in the middle of the Arizona desert and the Sonoran Desert. And so, that said, we end up having, we sometimes end up having to kind of spontaneously go. Tonight was one of those where we couldn't really pre-announce, because I was watching the weather very closely, and the weather right now, hopefully we won't have to end early, but the weather right now is iffy to the southeast of us, and there's some pretty heavy thunderstorms out there, and I'm gonna hopefully not have to close down. Before we end up moving much further, though, I did want to say hi. I see some new faces in the crowd. Okay, I'll say hi to those first. Waldo Hiding, how you doing? Where's Waldo? I see him. He's right there. Okay, and we had another one who's with us, and I'm trying to find that name.
One was Eliza.
Yeah, that's what I was looking for.
I think that's how you would say it. Ilyza.
Yeah, I think you're right.
Eliza Raquel.
Yeah. Well, hi, Eliza. Thank you for joining us here at SkyTour. Schedule live stream. If you haven't become a member, all you have to do is join. It's free. And you'll get these pictures. When we take these pictures, you'll get them and be able to download them within 30 seconds of us saving them from here. So we send them up to the cloud, and we save them on our server, which you will have a direct access to if you go here, skytourlive.org, and you go to right there to skytourlive.org, and you'll be able to go to our site. That's our portal. And if you go to the upper left, it goes to our channel. If you go to the upper right, it goes to our Patreon, so you can help support us if you like. We have value for everybody. You don't have to join, but if you do, that's great, because that's the only way that we get our income from this. I don't take any money from this. Daryl gets nothing from this. None of us in this are making any money. I'm a professional astronomer. That's what I do for a living, and this is what I do. And so it's kind of funny. I don't get paid for this in the same way. Eliza Raquel, nice meeting you at Contact in the Desert. Were you in my session, Eliza? I think you were, if I recall. So very cool. And Waldo Hiding is going to fall asleep to us. That's fine. We got some nice music in the background. You can hang out and listen to it. Nice. All right. And so yeah, this is looking nice, Daryl, tonight. Look at that. Let's zoom in.
Yes.
We're actually there. Look at that. Measure 13 looks really pretty tonight, guys. It's particularly gorgeous tonight. Look at that. I'm going to save it just like that. That's 18 shots right now that we saved. It doesn't need much more.
That's globular in the northern sky.
Well, yeah, if you can't see Omega Centauri.
Well, that's in the southern sky.
Yeah, technically. We can see it from this observatory, but the observatory wall's in the way. However, when we open up Benson, we already bought all the equipment, as people know, and we're going to set up the Benson telescope here in the next few months, and we're going to have that on an open pedestal with a articulated cover that's going to open and expose the entire telescope to the whole sky. It means we'll also be exposing it to wind, so we'll have to figure out a way to manage that. But Eliza says yes, so I'm glad you're in my session. I have photographs of that session, Eliza, so you're probably in some of my photos. But thank you so much. I hope you enjoyed that session at Contact in the Desert. For those that may not remember, I did a SkyTour live stream there. Actually, I did 4 things there. I did a lecture on interstellar travel using dimensional travel, which, interestingly enough, Avi Loeb has now come on board with, just so for the record. And I did a talk, which was a SkyTour live stream session. And I also did another talk on another aspect of astronomy and UAP phenomena. And then I did a Skywatch with Ben Hansen. And that was really fun. We actually had a Starlink launch go out. Well, it was actually a Falcon 9 go over our head. I'm not sure if it had Starlink in it. I don't know if it did. I think it was a resupply to the ISS, actually. And it went right over. It was just beautiful. It just went right over the whole sky. And then we caught it in our AllSky cam out in the observatory, which is this camera I'm about to show you right there. Here's our AllSky camera. Here's the Milky Way rising. It's going to get up here. This is the sunset. That's why it's light over here. This is west. See the compass rose. Okay. So you can see the stars here. This is the Milky Way rising. This dull glow right here, this is Phoenix, 80 miles away. You can't see this with your eyes when you're out there, but you can see it on a sensitive camera like this. Right there you can see there's a meteor that came in right there. It's that little streak. We can look here and look at the constellations coming up. Okay, we're actually looking right here at Measure 13. That's what we're looking at right there. Okay, and that's in the constellation of Hercules. This is the keystone of Hercules. See that shape right there? Yeah. And so that's pretty cool. And
do you know why they call it the keystone?
You'll tell me, I'm sure. I don't remember.
Sure. Well, you know, when you build an arch, like if you see a stone arch, there's always a big wedge-shaped stone up at the very top, and that's called the keystone.
Oh, that's right.
That helps to maintain the curve of the arch with carrying the load, distribute the load down the sides.
Okay.
And Pennsylvania is the keystone state, and I bet that has something to do with the same thing, but I don't know why.
I don't
But
know.
anyway, that's your.
Archaeological trivia for the night.
It's not just archaeological. I mean, cultures around the world have found that keystones are key to building a true arch.
Yeah, yeah, yeah. I want to say hi to other people that are here, by the way. I wasn't ignoring you. First one in was Rascally Rabbit. How you doing, brother? Good to see you. I said hello to Waldo. He's great to see him, too. Tim F. is with us. And we also have Stan from Two Rivers Observatory. How are you, brother? Nice to see you. And let's hope that we can keep doing this. Eliza's with us. Eliza Raquel, as we mentioned. Great to talk. And then there's Daryl guy. I don't know who he is. He's just all over the chat. Man, gosh, just won't go
You'll
away.
miss me when I'm gone.
Are you so sure? All right. And then Cosmic Ray is with us. And, of course, Mr. Django. He's off in Belgium. I'm glad he's joining us this morning. And it's morning for him. And then we have, let's see, there's some other people in here that I was looking at too. Tricia Ferreira has joined us. Hello, Tricia. Arizona Skies is with us. 24/7 live Arizona Skies. Nice. Yes.
And Ahada's here. Hi, Bonnie.
And Ahada 77, that's Bonnie. She is with us. Rocket City Astro is with us. Desert Dwellers here. What's up, man? Good to see you guys. Claudio Ramos from Chile is with us. How are you? And welcome back, I should say, because you've been here quite a lot in the past. And I think that's it for the early folks. You can see the red, a little bit of the red sunset light here. I'm going to try and get rid of that right now by doing a little color correction. So there you go. I color corrected it out. So now we have that. And so if I just bring this in, this is the mid-range. This will brighten up the stars, and you can see a faint satellite trail that's up there. We're zoomed in a little too. Let's zoom out so you can see. I'm going to show you the full frame. That's the full frame right there. Okay, it's 1.5 degrees by 1 degree in height. Used to be over 2 degrees across, but we got a different camera that allowed us to cram more pixels in a.
I see the propeller.
Yeah, you do. It's right here. The propeller is a artifact of the way the stars are. The way the stars are in this cluster. You have one line here, you have one line here, and you have one line here. And so that's what's known as the propeller. See, there you see it now.
You're kind of off there a little bit.
Well, I had to stay off center so people can still see the propeller.
Yeah, I know.
But yeah.
It's not like it's really, a three-legged dark thing. It's just, it's full of stars. It's just there's less stars in those areas.
Yeah. Yeah. And Waldo is not confused with the Keystone Cops. Not to be confused with the Keystone Cops. Yes, that's right. All right. Very cool. So this is good. This is we're going to do one more shot come in here because this is such a beautiful object tonight. It's actually really stunning tonight. The sky is really clear, so I'm going to make the best of this tonight. Okay.
Always has that nice red star to the left, too.
Oh, that's a beautiful star to the left.
Red giant, I assume.
Yeah, I'm gonna dig into that. Now, here's what we can do. Let's annotate this. This is gonna give us an annotation, and it will identify what's in here. It should identify a Messier 13, and maybe it'll identify this red star for us. We're now solving for this field, and it's gonna tell us what's there. Yeah, that's this star here. Look at this one up, Daryl. It's the Hipparchus catalog star 81848. Let's find out if that's a red giant. It's probably a red giant.
Yeah, give me a second.
And here's the globular cluster here. There's a lot of stuff in here.
818 what?
81848. Hipparchus catalog. HIP.
Yes.
Red giant. we'll save this image with the annotations, so it'll be up in the directory too for Measure 13, which is right here. Okay.
Spectral type K2.
Oh, okay.
Color is orange to red. Blah blah.
K2 as in K numeral 2 or K Roman numeral 2?
K.
Numeral 2?
2. Numeral 2.
Okay. So it's not a red giant. Okay, this is nice. Really pretty.
Yeah, since it's a Hipparcos star at 1,405.88 light years away.
Okay.
And
Desert
you
Dweller,
say, I
thank
guess.
you for coming. Have fun at work, man. There's a galaxy here, by the way, right near Measure 13 that we always see. All right, Waldo, you have a good night, and we will talk again soon, man. Thanks for stopping by. That's pretty. I'm sorry, Daryl, go ahead.
I don't remember what I was going to say.
Okay.
I will say that, well, here's one I've never asked you. I know in chat I usually post a link directly to the server,
Yeah.
like right there. This is where tonight's images are landing, and then Mark likes his other link, which I don't have. That's why I keep posting this one. But his other link will take you right to his page, I think.
You talking about skytourlive.org right here?
Right where?
That's, oh, you can't see it. Skytourlive.org. Yeah, it's right here. I'm showing them. You can't see it because you're not looking at it here. Skytourlive.org. Right up above here. That's our portal, and you can find all of this stuff there. The upper left is Skytour Livestream, the channel that you're seeing here, where you can watch previous streams. We've got like 400 previous, maybe more, 450 previous streams up there. It's amazing how that stuff mounts up over the years.
Yeah.
God, this is just beautiful. Holy cow, I'm stunned. I'm gonna zoom in more.
Yes, that is nice.
And that's with some sunset interference too. Let's see if we can clear more. Yeah, you see? Look at that. Nice. All right, let's do this. All right, now I'm gonna move this back. This is the black level, and this white curve is the average of the red, green, and blue curves. So, and it's right now, you should put it just to the left of the peak for the black level, because that way you're not losing any data. Once you get past this, you start chewing up your data and getting rid of it. As you can see, we're starting to lose more and more data as I move this over. Okay, but if we go back, then we get to see the whole thing. Just to the left of the peak is the best place. And so if we back out of this, this is the best location. Although, I mean, some people like going just past the peak to make it really black, but then you might miss details in here. You know, and then you have this guy, which is the mid-level, and this really brightens the entire scene. So you typically try to keep the black level and this guy kind of away from each other, because you get noise if they get too close. And so if you move these over, for instance, now you're going to get all this noise. Right? We don't want that noise. So keep it down here. We'll keep this black level just to the left of our peak, and we should be okay.
Well, it is a nice pic.
Yeah, it really looks pretty. Okay. All right. Well, this is good. We've got several saved to this already. So it's up on the server already, I'm sure.
Yeah.
And I'm now going to go back to our low light mode. And that's this. And there goes a Starlink satellite, maybe. And so that is... Okay, this red square is the size of our field. Right? And if you look at the numbers, to see this right, you have to turn your head to the left. Okay? And that...
Left, right.
Yeah, turn your head to the left, see? Because you turn your head to the left. Okay? So these numbers are right side up to your eyes. Okay.
Which one is the red star? The one at 6 o'clock and... Okay, right there. So, yeah, okay, left.
Yep.
I was thinking the one to the
That one?
upper... Yes.
Yeah, no, it's the wrong position. That star is this guy.
Okay.
All right, so that gives you an idea. And now what we'll do is we'll zoom out now. And because it's nice and dark, I was thinking we might want to head up to Virgo here. Oh, no, actually, we're going to go to T Corona Borealis right now and do our nightly view of it. Oops, I screwed up. We try to get to this star whenever we can. All right, there it is. And let's go. I just told the telescope to go, and you'll watch it move over my head here. There it goes. See it? You can see it moving right here. Okay, it's heading out, and it's moving into a very familiar field. And T Corbor, I think, is this star right here. But I'm going to find out because I'm going to do an annotate. It's going to show the previous annotation, which is not correct. We have to redo it, so I'm redoing it now. And let's see if we're aligned well. And we are. This is the Blaze star. This is T Corona Borealis. And this is a red giant star that has a white dwarf companion. And it's leaching some of its hydrogen gas as the star is bloated into a giant red giant. It's filled what's called its Roche lobe, which is the largest size it can have with a companion, or it won't leak any gas onto the companion. Because it's bigger than its Roche lobe, the gas is now leaking through the common center between them onto the surface of the white dwarf. And that's what we're seeing happen here. And that's why this star, if that went nova right now, we would see it live because we're in a live mode here. We're just looking at this live. We're not taking a picture. We're taking short 1 second shots and then showing them to you. We're going to take a 15-second shot here. And I'll put in 15,000 because that's in milliseconds. I'll get rid of the annotation for now. Go back into the live stack, which will have the previous image in the buffer. But because of this, I'm going to clear this out. And we should see our next image.
When Mark says red giant, T Corobor is actually it's a double star. It's a red giant and a white dwarf, as he said. What we're seeing now is actually the red giant. We can't see the white dwarf because it's so small and so close to the red giant star. We won't actually see the white dwarf until it goes nova. And then that's what we'll see instead of the red star.
That's right, for a few days.
For a while, yeah.
It's only going to last a few days because the red giant's the size of the Earth. I'm sorry, the white dwarf is the size of the Earth. The red giant is quite substantially bigger, obviously, than the sun even. So when this star starts to fuse the hydrogen on its surface, it's going to grow in magnitude to be quite a bright star. You know, magnitude, what, 2 or so?
Yeah. If you can go back to Stellarium for just a second.
Show them Alphecca.
Yeah.
This is our star right here, guys.
Yeah.
Let me just bring up the annotation here. Okay, let's go to this guy.
So what Alphecca there, you see the shape of the crown, that cup shape there. Alphecca is the jewel in the crown, and T Corona Borealis is there just below the second star from the left end of the crown.
Where the STLS is.
Yes, and when T Cor Bor blows, it's going to be comparable in brightness to Alphecca. So it should really stand out. You'll see an extra star in the crown.
So there'd be like an extra jewel in the crown.
Yeah.
Cool. Yeah, and so the nice thing is this planetarium program is called Stellarium, and anyone can get it. It's free. But we're using it in conjunction with our telescope, and we're having our telescope be driven by this application, be driven by this application. We're having our telescope interface to several different applications. And that was the magic of getting this all running together when we did it.
Oops.
Don't spill your coffee cup.
If you can find your way around in the sky, if you could pull back just a little bit there, Mark. You see Arcturus there toward the upper right. That's the fourth brightest star in the sky. And if you draw a line from Arcturus to Vega, which is a little out of frame on the left, there's Vega. If you draw a line from Arcturus to Vega, T Cor Bor is about 1/3 of the way from Arcturus to Vega.
Right. Yeah, so basically you're saying all we have to do is start from here. Right. Start here and then just I screwed that up.
Marianne and Izabela are here. Hello, Izabela. Hello,
Hey,
Marianne.
Izabela. Hello, Marianne. Yeah, so draw a line from from Arcturus to Vega, and as Daryl said, just under halfway is the location where it will be in the crown. But you can actually just look for the crown because you can see the crown. Pretty good. But that's
okay.
Cool. All right.
Thank you for indulging me.
Yeah. Kate Chassie, how are you? Nice to see you. Nice to see you, Kate. And Genghis is with us. Good to see you as well. All right. So let's go back and see where we are with our shot here. Okay, so here's the blaze star. It's annotated, as I said. We're going to save the annotation so you can see it. And that's going to go to the M13 directory. My mistake. Sorry. I will change that. So I'm going to change this, and it's going to give me a nag T Cor Bor. All right. Yes. My fault. It nagged me. I should have listened. So now I will save it, and we'll be good. All right, and then we'll save it exactly as seen. Okay, now
I read somewhere today when the nova occurs,
yeah,
it may hit peak brightness and start declining in like within the space of half a day. I mean, it'll stay bright for, they're thinking maybe a week, but it'll brighten so fast that it'll start dropping in brightness within like a half a day.
Yeah, if you think about it, the runaway fusion is going to occur on the surface of the white dwarf. And that runaway fusion is going to, wherever it starts first, it's going to propagate out. And so because this is about the size of the Earth, the time it's going to take for the propagation of this runaway fusion is going to be about a day or so. And then you're going to have a residual brightness that's going to hang out for just a little bit longer. So I would say 3 days. That's my guess.
I wonder how thick that hydrogen layer is. I mean, are we talking inches, feet, miles?
Um,
Can't be very much because it's really high gravity there.
yeah, but keep in mind that it's going to distribute evenly around the entire Earth-size orb.
Well, yes, of course.
But there's a lot of it coming from the red giant through that Roche lobe filled, central center of rotation. So there could be quite a lot of it there. But as far as how much, I don't know. But remember, hydrogen atoms are the lightest ones there are, right? And we're looking at this point at nuclei, not even electrons, right? So we're only looking at protons, a single proton. So to get a mass that approaches 1.44 solar masses, there's a lot of hydrogen that has to go there. So I'm going to guess that it's actually a pretty deep. I'm going to guess it's a pretty deep depth of hydrogen there.
Well, it doesn't have to be 1.44 masses of hydrogen.
No.
It's the mass of the white dwarf plus
That's correct.
however much hydrogen to make it reach the fusion point.
Well, yeah, and if it reaches 1.44, that's when it'll explode in a supernova. So that was the first thing I wanted to mention. But if it's not going to go, if it's just going to go nova, then whatever the density is at the white dwarf, at this particular white dwarf, they're all about the same. Then there should be a theoretical volume of hydrogen that will reach the right temperature, which is about 15 million Celsius, to fuse. And when that happens, it'll be a runaway fusion, and it might happen in patches on the star. It depends, and it may happen. It may happen right at the feed point where the hydrogen is striking the white dwarf from the red giant. That would probably be the densest knot of material, and that's probably where it starts and propagates around the star from there. That's a guess, but I would think that's what it's going to do. All right, we're going to save this exactly as seen here. Here we go.
Star even looks red now.
Well, yeah, it does. I will zoom in. So now for those wondering how come we don't see the white dwarf, well, the white dwarf is literally within the glare of this red star. We can't see that. Okay?
Would you call that a spectroscopic binary then?
I would.
Okay.
A binary that's only, or two binary stars that are only visible by looking at the spectrum and seeing that there's a spectrum of more than one star there.
Yeah.
When I was classifying spectra, when I was getting my degree, I was actually doing part of the classification. I was classifying spectra, and one of the trick questions that we were given on one of our exams was a spectrum which had more than one star in it. It was actually a spectroscopic binary, and if I recall, I got it right because I could actually see the two spectra overlaid in a manner of speaking. Because when you get used to the different series of lines, you get used to the spacing that they have, because like hydrogen has several series, a Balmer series, a Lyman series, and so forth, and their lines are spaced out a certain way. So when you look at a spectrum, you know what to look for with the hydrogen lines. You kind of know what the spacing looks like. So if you see several spectra overlaying, especially other elements like calcium, you can figure that something strange is going on. And so you literally can try and figure out which star is which. And it's kind of a neat exercise. A little maddening if you're not sure what you're looking at. Okay.
I think I've told this story before, but I'll tell it again.
Okay.
My spectroscopic binary back in 1993, I think it was November, there was a really nice lunar eclipse, a total lunar eclipse, and I was watching it through my old Celestron 8-inch telescope out in the front yard, And the moon was up in Taurus, very near the Hyades. And as the moon tends to do, it moves from west to east across the sky. And the progress of the lunar eclipse is actually due to the moon's motion through Earth's shadow as it orbits the Earth. And it was looking really cool. Big red moon in the eyepiece. And there was a middle and bright little star to the left, to the east of the moon. And I noticed that the gap was closing, that the moon was going to eventually eclipse or occultate that star. And I kept watching it, and finally the limb of the moon hit the star. And stars are so far away that they're basically just mathematical points of light in the sky. And the star should have extinguished instantly, but it did not. The moon hit the star reduced in brightness very discreetly for just a moment, an instant, and then it went out. And I can only figure that what I saw was a spectroscopic binary being eclipsed by the moon. I couldn't separate the two stars; they were too close together. But the limb of the moon eclipsed one star, and then a moment later it eclipsed the second star. So the light dropped by half, and then it went out completely.
No. I wonder if that can actually happen. I'd have to look that up and see if anyone else has ever seen that.
I believe they can.
Want to say hi to Randy and Diane up in Pine Top, Arizona. Hey, guys. That's a shout out for you. I think I said hi to you, Bonnie, on Ahata 77, but I want to say hello again. Sam S. is with us. Papa Tom is with us.
I got some great pictures of that eclipse. I actually made money off that. I sold a ton of prints of it.
Wow.
This was back in the days of film still.
Okay.
Anyway.
That's cool. Alright, so I gotta wait a little longer here. Alright, let's go down here a little bit. What do we got here? What's our altitude here? Alright, we should be able to see this one. It's a nice night, so we're going to check it out. This is called the Blue Horsehead Nebula. Telescope's going to move quite a lot.
Can I bore you some more before you leave Stellarium?
Yeah.
Okay, when you see Libra there on the right, the two brightest stars there at the top and the bottom, and then if you look over toward Antares there in Scorpius to its lower left, you'll see 3 or 4 stars in a curved row to the upper right of Antares. The top one is called Acrab, has other names also, and the middle one is called Deshuba, and the third one down, I only ever see it given as a Greek letter. Deshuba.
Ada. It's also known as Fang.
Okay, that's right, yeah, because I looked that up the other day, Fang. So Acrab, Deshuba, and Fang. Deshuba is the forehead of the scorpion. And Fang, okay, you can't depend on the artwork in Stellarium.
Yeah.
They took a lot of license with the artwork. But you could say that Acrab, the upper one, is like the scorpion's left elbow, and Fang is the scorpion's right elbow. And then if you look back up toward Libra, that top star and that bottom star, well, draw a line from Acrab to the top star and from Fang to the bottom star. Those are the claws of the scorpion. The top star's name is Zubanesh Shemeli, and the bottom star is called Zumanel Janubi. And I may not be pronouncing those right. Scorpius is an ancient constellation. It's probably one of the oldest ones we know of in the sky. And Libra used to be the claws of the scorpion. And it turns out the Romans changed that. Before the Romans, that was always the claws of the scorpion, extending upward from the elbows of the scorpion.
And you can see why.
Yeah.
Making Scorpius even bigger in the sky.
Yeah.
All right.
Okay. Thank you.
That wasn't boring. That was cool. All right. So now we're over here at the Blue Horsehead. And we're going to try and check it out. And the Blue Horsehead's a very interesting nebula. And it's associated with, let's see if I get it right here. These two stars, which are right here. So we're gonna move this over a little bit. So we're gonna go eastward right now. There we go. And then we'll just move up a little bit.
I always imagined the scorpion figure, guys standing watch by the fire at night.
Mm-hmm.
You know, they're staying up all night while everybody sleeps, or standing watches, and while they're whiling the time away, they look up in the sky and they saw stars in patterns, and they made stories about them. And when you see the scorpion, that's one of the few constellations that really looks like what it represents. And that's, you know, back in the days of cavemen, well, they used to have scorpions running around, and golly, Og, look, that looks like a scorpion.
Yeah. Well, we certainly have lots of Scorpius in Arizona. Okay, I'm just going to align this right here.
There were some here, supposedly. I've never seen one.
You just need ultraviolet light.
In the wild. Yeah, I've heard that.
Yeah, I use UV lights to hunt them out in Arizona. And actually, you go to parking lots at night and you shine your light down, you see all these ultraviolet splotches from all the scorpions that have been killed over the years. Unfortunately. Okay, we're going to do a 25-second shot here. And we're going to move up to 250 in terms of the brightness, the setting here for the sensitivity. All right, so you can see some hazes here. That's related to this nebula. So we're going to go into our stack here, clear the previous stack, which is looking really nasty because things changed. And then we'll get our first shot. Okay, let's reduce our brightness. You can see blue in there. So this, you can see that's our nebula in here. That's the nebula, the Blue Horsehead. The halos are an artifact of our system.
Ray, I'm going to quote Wild Bill Hickok from the show Deadwood. Let me go to hell the way I want to. Thanks.
Oh, was he being picky with you?
He's being Ray. Mark, will you excuse me a moment, please?
Sure.
Right back.
Okay.
I think I see a blue horse head.
You do. See, there it is.
Yeah. Be right back.
All right. Okay, so by doing a little bit of that, let me color correct here. There you go. And we'll bring this here, okay, accentuate a little bit. Now you can see this blue nebula. Well, why is it blue? Well, see, this is dust. And stars in this region, particularly Jabba, this one, like Jabba the Hutt, okay, these stars are of course bright, and they have a spectrum from red, orange, yellow, green, blue, indigo, and violet. And when they're bluer stars, okay, like if we go to Stellarium, the star Jaba is actually a B25, a B2, so it's a very not as blue as an O star, but the next one down in the list is a B, so OB, AF, GKM. You know, from hottest and bluest to coolest and reddest, the B star is pretty hot. So what we're looking at here is this B star that is really got some bright light, and so what happens is that light is hitting the dust particles in this cloud, and those dust particles are scattering the blue parts of the spectrum, and they do it very well. And small particles and particulates, whether in a star cloud like this, or a dust cloud rather, or in an atmosphere, will scatter the blue light. So this nebula looks blue for the very same reason our sky looks blue. All right, the light is scattered in the short wavelength light, which is blue, in the star spectrum, and the dust particles are small, and they just scatter the blue light very, very nicely. And that's what we got here. So that's why it looks blue. There's that nice sharp edge right here. Let's see if I can enhance that a little bit. Let's watch it here. Oh yeah, so this enhances that quite a bit there. Let's go back. Now let's do some color correction here. See if this helps us. Yeah. This is only 8 shots so far because we're doing 25 seconds apiece. Hey Judy M, how are you? It's always nice when Judy shows up. Okay, let's see what else is here. By dragging this middle one over, we're gonna make it noisier, but we'll see other data that might be there. Yeah, see that? So we have data down here. This is a really solid blue nebula right here. Makes sense, stands to reason, because Java, this B2 star here, is very, very bright and sitting there. So we'll drop this down to get rid of the noise. I'll pop this one up, and it kind of also shows us what's really there in the background. See? And I'll pop it back down. Hey Stuffy, what's up? Nice to see you. Yeah, so we'll let this come in here a little more.
Trisha has an interesting question.
Trisha Ferreira?
Yeah.
Oh.
Down at the bottom. What's the strangest creature name in space?
Oh, like
is there
I
a
gotcha.
slug constellation?
Well,
There's not a slug. There's some weird animals,
yeah.
especially when you get down to southern sky.
Yeah, we have a sea monster.
Cetus.
Yeah.
Cetus was a sea monster back in the day. Today they just say he's the whale.
Yeah.
It's the same monster that was threatening to eat or kill Andromeda when Perseus rode to the rescue and saved her. The sea monster.
That's right.
The northern sky constellations, there are a lot of animals there. They're all pretty classic animals. I mean, when you get down to southern sky, well, it was really discovered scientifically, after the invention of the telescope, and people started studying the southern sky, Herschel and others. They picked all sorts of strange names for southern constellations. There's one called Musca, M-U-S-C-A, which is a fly.
That's right.
There's Pavo the peacock. There's many others I can't think of offhand. There's a sextant. There's a furnace.
Fornax.
Fornax the furnace. One of my favorite unusual names for a constellation is Camelopardus, or Camelopardalis, they
The
say.
giraffe.
It's a giraffe.
That's cool. Well,
Let's see.
I like
That's,
Delphinus, which is a dolphin.
that's one of my favorites.
That's near Cygnus.
Yeah, well, it's right next to Aquila the eagle.
Yeah.
Uh,
But if we back out and go to the northeast here,
Delphinus is one of my favorites. It looks like a little kite up in the sky,
it does.
just below the bottom, just to the left of the bottom star of the summer triangle.
Yeah, and to find it, you just got to go here
There it
through
is.
the Milky Way, and then here's Delphinus right there.
Altair and Delphinus.
Yep. And if we were to turn on the artwork, you can see the dolphin there. Pretty cool. And you just got to follow the Milky Way. So we'll be following the Milky Way. We're going to do some of that here a little bit as well, to the limits that we can, obviously. Let's go back to where we are.
It's going to be that time of year.
I know.
Yeah. Well, the whole summer triangle is up now.
Yeah, I'm thinking maybe we're going to go check out Rho Ophiuchi after this. But see, we're now getting filaments in here, and we've got 18 shots. What's interesting about we're stacking. What's happening is we're taking an image, then taking a second image, aligning it with the first, and slapping it on top, and making an image sandwich this way. This image sandwich, the more we stack them, the more the subtle detail comes out, and the more the noise gets muddled and removed. So it's pretty cool how this works. Really nice. It's a really good way to do it. Now, we could be taking black and white shots, and if we did, then this image would look like this right here. This is a black and white image right now. All right. So we're taking a full color image, so you get to see the color. We could also look at this the way I looked at many nebulae when I was working on my astronomy degree, and that was by going into a negative view and looking at the inverted view of it. And I would usually do that in black and white, so it would actually be like this. So I would see a black and white image like this. You might say, well, wait, I don't see the nebula too easily. And you really don't. But when you take a longer exposure and you bring this into perspective, you can really see the colors show up very, very nicely. And you can see the filaments very, very easily. And we use magnifiers too to actually look in magnifying software to look at these nebulae. But this is looking pretty. Let's I'm gonna move this down, and I'm gonna take this and get rid of the telescope for a minute, and just go here and just look at this for a little while we're acquiring images. If you want to know what images we have or how many we're acquiring, you can see down here. Okay, we have actually acquired 23 stacked frames. We've ignored 0, meaning our guiding is perfect. And we can see this right here. We can see this beautiful arc. This is what's neat about this nebula, is this arc of blue right here. This blue arc is actually you're actually seeing a separation of density of the dust particles that are in this nebula right here. So there's fewer here and more here. So this star's light is being scattered by the dense particles here of dust, and less so by this stuff over here. See, now you had a whole lesson in reflection nebula, which is what we call these. All right, let me bring this up for just a minute and come over here, pull this down, try and obviate some of the noise for a bit.
Can we do Antares and Messier 4 before we leave Scorpius?
Yeah, we're going to do Rho Ophiuchi next, and then we'll do that. Just remind me. So that's pretty right there. That arc is really nice. And just so everybody knows, I have a big curved screen in front of me. So I've got multiple windows displayed. On the left side of the screen is the observatory feed. On the right side is the broadcast feed. So I might be looking here when the thing I'm looking at is up here for you logically, but it's actually, I'm seeing the raw feed on the left and the production feed for the video broadcast on the right. All right, so heads or tails of it. Yeah, that's what Daryl sees. It's all green stuff coming down.
Okay.
Yeah. All right, this is pretty. I feel like I'm in the way here. So what I'm going to do is I'm going to reduce the size of this a little bit. When you reduce the size, you can actually see a little better what's going on. This is all nebula right here. That's really cool. And let's dock this up again for a minute.
I assume that's the horse's nose to the upper right.
Actually, I would have to wonder. I don't know.
Well, try to imagine a horse head, a blue horse head. That's sort of a horse head shape. His cheek or jowl is to the lower left. The bridge of his nose is above the bright stars, and the tip of his nose would be toward the upper right.
Yeah.
That's just what I see.
Yeah. Hey, Paul Martin. Paul Martin is joining us from Durham in the UK. Very nice to have you with us. We have Mr. Django from Belgium. We have Claudio Ramos from Chile with us. We have a lot of people from the United States. We have, I don't know where our Australian friends are. And David Schmidt from Bangkok isn't with us tonight.
I haven't seen him in a while.
Yeah, he's got to be around.
Hope he's okay.
Yeah.
He's a good guy.
Yeah. He's one of, in the Australian, we have Australian folks that join us as well. Excuse me. Yeah.
Ship 26 is from Australia. He's from Queensland.
Oh, really? Where'd I miss that from? Did I miss someone?
He just showed up in chat. Down at the very bottom.
Ship 26. Queensland, Australia. Very nice. Thank you, Ship. Nice to see you. Nice to see you here with us tonight. Yeah, I think we have folks from Melbourne that come in. One from Perth when they come in. I'm actually doing a talk in Perth in a few days. I'm not flying there. I'll be doing it through Zoom. I'd rather be there. So I gotta do that. That'll be fun.
I saw a new Astro Backyard vid today.
Mm-hmm. Trevor?
And yes, at the end of it, he was dropping hints that he's going to Australia.
Mm.
He showed Australia on a map, and then he wagged his passport at the camera, so I guess that means he's going to Australia.
That's cool. Yeah, we want to find a way to set up a telescope down in Australia as well. We got the one in the Sonoran Desert, which is this one you see here. We got the one going in Benson, Arizona, 200 miles to the southeast, in Arizona still. And then we have one going in here, just 100 feet from me, in Connecticut, and that's going to be a solar observatory. And then we're going to try to do several things at the same time. One of them is going to be make a mobile observatory that we could drive around the country and take to your town, okay, and put on talks with a real live observatory and astronomer for public, and then we'll get the towns to underwrite that for us, I hope. And then we want to see if we can get a telescope in the southern hemisphere, and that would be kind of cool. Francis Palmer, how are you doing? Nice to see you.
Get a telescope in the southern hemisphere, you're not going to get any sleep.
I know. Well, solar observatory, same thing.
Oh.
Francis Palmer's from the UK as well. He's Rye. He's from Rye in the UK. Okay, I'm going to save this just like this. There's it doesn't look like it, but there's an awful lot of data in here, believe it or not. Izabela, who is one of our Uber users and dear friend of SkyTour Livestream, knows, because I showed her how I do processing, and she's taken it and run with it very well. And I got to tell you, she's also written an application, which I do want to show you at some point, but not tonight. And that application is the SkyTour Stargazer's Companion. It's an app that we're going to make available on the iPhone, on Android, the PC, and the Mac. And it allows you to look at everything we've done since 2021. You'll see all the images out there, and you can look at every single time we looked at the Blue Horsehead. You can look at every single time we took an image of the Pleiades. And then what you can do on your own is take those separate images, and using other tools, you'll be able to compare them and see if you can see anything new in them. Izabela has found some things, like she's found asteroids in some of our other photographs that none of us realized were there because they look like stars in a still photograph. You know, it takes a lot of time for them to leave a trail if they're far out anyway. So that's pretty cool. So I thought that was pretty neat. And so that application, we're going to try and make that available as soon as we can. I have to just figure out the logistics, and I have to pay a monthly fee, which is why it'd be great if you guys could help us with the Patreon, because then we can support making the app, because we're going to be paying at least $25 a month or more to support the app on the different platforms. And that might be per platform, I'm not sure. Izabela knows everything about that. She's been working with that.
Well, you'd think they'd cut you a break as a non-profit.
Yeah, they do. Actually, it only costs us half as much.
Okay.
Yeah. So that is the $25. Normally it's going to be like $50. So we I think. So we actually get it for cheaper because we're a non-profit organization. Okay. And now what I shall do, all right, is I'm going to bring back the telescope here, move this over. There we go. And I will save this one more time and save it exactly as seen. Wonder what the annotation would show for this. Let's find out, shall we? Let's do the annotation. Again, these are the old ones, and we're now doing a plate solve here. You should identify Java. Yeah, it did. Okay, interesting. And there's the star. Hipparchus 79374. Looks like V Scorpii, 14 Scorpii, Java. There's several names. Different catalogs. List them. Hipparchus is a catalog. V Scorpii. That might be That's one. Then we got 14, SCO, and then Java. Good. And we'll save it just so we have the annotation to save with it. All right. And then we have the nebula, which you see here. The nebula is rather extensive, as you can see. So it goes all the way outside of our view and beyond. Okay. So let's now go here, go back to one. It's a beautiful night, my gosh. 1 second view. That's our low light view. Okay. And now okay. Let's go now to what are we looking at there? We want this. We're going to go here. IC 4603. That's actually along with the Rho Ophiuchi Nebula. It's going to be kind of a mix, but it shows beautifully. All right, so there we go. Telescope is moving a little bit. Won't go far. And there you go. And let's go see where we are. Okay, and so we're looking at this location right here, and those two stars might be those two stars. I gotta see. We gotta see where we are. Let me zoom out. Okay, we're gonna do a 15-second finder shot here. That's 15,000 milliseconds. And then we're gonna come in here. Into our stack. That's what's really there, hidden in the background. And let's see. Yeah, it's those two. That's good. Okay. So we're going to come out of this and move down to those. And 1 second. And now we'll just move over, head east. You'll like this because you can see the dust and the colors and the amazing interplay of this nebula just north of the star Antares. Oh yeah, it's really going to be pretty. And I'm going to move south because I want to center this one in there. So the Rho Ophiuchi Nebula is out of our view to the top, but that's okay. This is perfect. All right, and what's happening now is we are searching right now. It just says searching up there. We're searching for guide stars. As you can see, we have started the guide, and this is going to be a 30-second shot. Okay. So 30S or 30,000, either way. So this is going to be a nice shot. And we'll see this gorgeous nebula show up here. Let's go in here. Let's get out of this. Go into deep sky mode. Okay. This region is just so full of dust and streaks and everything. It's just beautiful. It almost looks fake. Almost looks fake.
A lot of the dust is being illuminated by Antares.
Yeah. Look at that beautiful dust. Oh, man. Let's just go out a little bit here. So these two stars are causing a lot of the dust to be illuminated right here, causing a reflection nebula. Let's color correct. So change the color slightly. All right. And we have a nice gradual hump here because there's a lot of data here. Look at that. You can already see streaks and, of course, a satellite coming through. This is beautiful. And we're going to call this the Rho Ophiuchi region. It's not the Rho Ophiuchi Nebula. That's out of shot to the top. But it's the Rho Ophiuchi or the Antares Nebula region. Kind of nearly the same. Don't worry about that satellite trail because that's only existing on a few frames, and the dark space behind it is going to gradually overlay this as we capture more.
Might look good in processing.
Oh, it'll be beautiful. 3 shots we've taken so far. Yeah. So I'm going to take this and move it down a little bit just to see if we can soften the noise. Yeah, look at that. That's actual stuff you're seeing, guys. A little reddish nebula in here. That's softly glowing hydrogen gas. The blue is dust that's scattering the blue light from these stars here. It's a 3-dimensional universe. Let's see if we move it closer. If we can. This is called a push. And you can see what else is lying in wait here. Obviously, we don't want to do that right now. We want to let that develop first before we start pushing stuff. Hey, Curtis Horn's with us. How you doing? And just so you see where we are, okay, we're at this location. It's called IC 4603. And it's actually a bipolar nebula. And it's actually this guy right here. All right. But it also has this dust around it. You know. So we zoom in on that. We're not quite ready to zoom in. But when we zoom in later, you'll see what this looks like, what this nebula looks like. A bipolar nebula means that it's got 2 distinct lobes. Okay. The dumbbell is sort of a bipolar planetary nebula because it's got 2 distinct lobes in it. And this is a bipolar nebula because of this. It's 2 distinct lobes. Yeah, this is pretty good. It's a really good night. There we go. Nice color correction to help you. Now, if we invert this, you can see some of the detail that's hiding in the dark here. Okay, see these areas that are light? Those are actually dark streaks inside here. And we can bring them out by doing this. You can see a bit more detail. So pop back into non. Francis, that's a good question. Oh, okay, yeah.
Paul Martin has a question for you too.
Yeah, okay. Francis and Paul. I'll answer Paul's first because he was first in there. Are you using any filters in this side? Yes, I'm using a filter that basically gives us 3. They're not full narrowband, but 3 swaths in the narrowband filter arrangement, which gives us the hydrogen alpha, the oxygen 3, the sulfur 2, but it's all in one filter, and we're actually they're kind of slightly broadband, meaning they're thicker than the really thin band passes that we normally get in those filters. And that allows us to see all of this at once. And the reason I'm doing that, rather than take separate black and white photos in the hydrogen alpha and the oxygen 3 and the sulfur 2, is because I have an audience around the world watching for cool stuff, and they want to see it right away. And this is an immediate. This is immediately beautiful. With the next telescope in Benson, we're actually going to have one of these filters on it, and we're also going to have narrowband filters because we have a filter wheel for that one. And we're going to be able to take images of it like this in one shot of this guy, and then take images in hydrogen alpha, O3, and sulfur 2, and then combine them to show you. It's going to be much more elaborate of a setup. Not much more elaborate. It's going to do different things in this one. This is a wide field telescope that views the night sky. Our next one is going to be one that is going to be much more focused and magnified. So we're going to see a lot less in each image. Our view of the next one's probably going to be like this. So it's going to be a little bit about like that. So we'll be able to have this whole nebula filled. This part of the nebula will fill the whole image. Look at this.
Paul has a follow-up question.
Okay, and I have to answer Francis first. Oh yeah, it's the UHCS filter, Paul. Sorry, UHCS. And Francis says, "How thick is the dust and gas in a nebula? In a nebula, if you could be in it?" Excellent question. First of all, if you went racing through this in a spacecraft, you might never hit any of the dust, and the reason is because there's not a whole lot of dust in it. It's just that because it is so extensive and so deep that it looks like it's really thick. This area here, if you went into this one, you might hit some particles going through. Okay? But you only have a few particles every centimeter in these clouds. Whereas on the Earth, you've got like 10 to the 20 atoms per cubic centimeter, or more. So it's a very, very different density relative to what we're all used to. So this is gorgeous. You can see the dust here looks brown. That's really what it looks like. That's because it's carbon and silicon dust from stars that have gone supernova and littering the universe with their debris. That's what we're seeing here. And our bipolar nebula is starting to show up really nicely. Let's see if we can drag out a little bit more data from this. Isn't that beautiful? It's looking really nice. Nels Johansson, how are you? You're up in Washington. Okay. Great to see you, Nels. Thanks for joining us. Okay, this nebula that we're looking at is down. Let me show you. It's down in Scorpius. Right here. And we'll be able to go down here and look at the Crab Globular Cluster. This is Antares. We're quite close to Antares. In fact, you'll see some of the Antares Nebula down here. This red is starting to leak into our view because that's ionized hydrogen gas. But this artifact here is what's called amplifier noise from our camera. We get rid of that in post-processing. This is really pretty. I'm going to pull this down a little bit. And let's do this. Wow. We're getting some nice detail, Daryl.
Mm-hmm.
I've got a filter here called a full width half maximum filter, and what it does is it allows me to set the maximum star elongation if the tracking is off, and it will reject any frames where the tracking is a little bit off. And as you can see, we've got one here, 7.41 versus 6.51. And so that one was rejected because I dropped this down to 7.3. I'm actually going to drop it a little bit lower to just take into account. We can go to here, 6.89. So we want all of our stars to have that same kind of quality to them. And we have 19 frames so far. I'll save on the 20th frame. There we go. So that's saved. And I'll save it exactly as seen. So the thing is, if you go out and look on our server, here's the image that you can download for yourself. This you can take down right now. Alright, because it's heading up to the server. Now, as far as getting rid of the noise and these artifacts, that's what we do. And if you want to join our Patreon, then you can get these more highly processed photographs at certain levels on our Patreon. It's just, we got to do something. Fantasy says, okay, I got a question. I'm trying to impress someone who is a Leo. What measure object would Guy say is the most stunning object in your opinion? In Leo, I would have to say that you're probably looking at the Leo triplet. If you want to impress someone, you got this beautiful galaxy with a dark lane through the center of it, just above, and then you got these gorgeous galaxies below that have lots of structure and personality. So the Leo triplet is your romantic object for Leo. Daryl, you concur?
Sure, why not?
Yeah, he doesn't have too much energy with this, as you can tell.
I'm kind of partial to the hamburger galaxy myself.
Yeah. But the Leo triplet is a nice trio. Hey, you don't owe me. Well, fantasy. If it goes well, then we'll talk. I'm kidding.
I will gladly pay you Tuesday
if I can
for
have
a
a
hamburger today.
Not now, Wimpy.
Yep. You can see the dust wisps now. You can almost see the three-dimensionality to this cloud. These stars are embedded inside this dark dust, and they're illuminating it. And these clouds here are probably here in the foreground, and these are in the background. The ones that are blue are in the background. So they're not scattering the light, at least from this side. And there's some density there. And to answer the question finally about how thick the dust would be, it's many, many light years in thickness. Many light years. So that's pretty cool. So, Sam S., what are you talking about? Oops, sorry about that. Go away. I have to get rid of that and make sure that doesn't ever show up anymore. Okay, 7.27. We had one more rejected frame just there. Out of 25, that's not bad. I'll save this here for the Rho Ophiuchi region. So these are these clouds. When you see a lot of these dark, dusty clouds, they're usually made of molecules. Carbon molecules. Carbon is wonderful. It can bond to many, many things, and itself as well many times. So carbon can bond to other carbon molecules, sometimes with multiple bonds to another carbon molecule. And so we can have carbon molecules like that in these dust clouds, especially like in dark clouds like this. This is a dark cloud, by the way. Okay. And we can see that this cloud is denser, looks darker, But the edges, as we get near the edge, you can see it gets lighter, and so it becomes brown again. But you're looking at different densities. The darker they are, the more dense they are, typically. That's really something. Okay. And now we'll go to, after this, we're going to go to measure 4 for you, Daryl. We already said we would.
Okay, good.
Okay. We got 27 frames here. I'll save it, and I can stop here. That's okay. Not much will be different between 27 and 30. All right. So there you go. That is this cloud complex of dust just north of Antares, which is the eye of the scorpion, heart of the scorpion. And now let's go back and go into our low light mode again. And
Astro Backyard was calling the Antares area the tail of the scorpion in a recent video he did.
okay.
I didn't have the heart to tell him.
That's okay. All right. So now let's go back to our planetarium that we use. And we're going to go now to this special globular cluster right here. After this, I think we'll go up to Alniyat and look at this gorgeous ring of ionized hydrogen.
We haven't done the comet yet.
I know it. I hope we can still see it.
When you see Antares there, folks, as Mark said, that's the heart of the scorpion. That is the closest thing we have to Betelgeuse in the summer sky. Antares is very similar to Betelgeuse. It's a red supergiant, and it's another prime supernova candidate.
Yes.
And the globular cluster Messier 4 right there. It's the closest globular cluster to Earth. If I remember right, it's about 4,000 light years away. And Mark likes to say that globular clusters are halo objects, but if any of them is inside the galaxy at this time, I would say it's Messier 4.
Yeah, Messier 4 is probably right now cruising through the disk of our galaxy. All right, we'll center it up here. Let's see where we are. We're going to center it up in our crosshairs. And then just jog to the east a little bit. One more jog, and then we're done. Here we are. Okay.
If you were with us early tonight, folks, Messier 13 globular cluster was the first item we looked at tonight.
Yeah.
And, well, about all they have in common is they're both globular clusters. They're very different in nature.
Yeah.
Messier 13 has a lot more stars in it than Messier 4 does. But still, it's a very nice globular cluster.
Yeah.
And when you get the image of it, it sort of looks like it has a bright line going down the middle. You can see it right there.
Yeah. And what I'm going to do is I'm actually going to move us a little more to the east. And there's a reason why I'm doing that. And that's because the Antares Nebula is encroaching on the location of M4. So if we go here, you'll see some of the red glow of the ionized hydrogen that is surrounding Antares here, and dust. So I moved this to that side just to show it. It won't hurt the view of the Messier 4. So we're going to do a 25-second shot of this, and let's go into our deep sky mode. drop in and we'll look at the last photo of the Rho Ophiuchi. Rho is a Greek letter. Ophiuchi is from Ophiuchus, the constellation. And so we're in the Rho Ophiuchi. The Greek letter is a symbol of the brightness of the stars in the constellation, alpha being the brightest, omega being the dimmest. All right, so here we go. All right, I gotta increase our full width half maximum slightly because the first image was rejected. It wouldn't have been round. C&D boys with us. Hey man, what's going on? Christine is here from where are you from? And Wayne is here. Wayne Pinkham. Wayne, what are you talking about, Korea? You're not from Korea. You live right near me. Unless you're in Korea right now. That'd be pretty interesting. Okay. So there's Measure 4. You may notice it's not alone. There's another cluster right here. And if we go back in here, all right, you can see the Antares Nebula here now. This is NGC. I'll move us over a little more. Right to there, because that's where we are. This is NGC 6144. That's another globular cluster here. This one, all right, is 29,000 light years away. And Measure 4 is given here. Has a distance of, well, it says 7,000 light years here. But I don't know who's right or wrong in this case.
Yeah. I'm just going on memory.
Yeah, that's fair.
My memory ain't what it used to be. I can look it up if you really want to know.
You don't need to.
All right.
So as I said, you can see here the Antares Nebula is encroaching right here. So we're actually seeing that. That's pretty cool. Let's go back to our histogram and let's go here. Let's move ourselves down a little bit. What I'm going to do is I'm going to back us off this here to get us more of our darks, and you see more detail coming. Look at that. More nebula all of a sudden shows up. And there's more out here. That's pretty cool. And let's see what it does. It wants to go here, which is okay. I would come up the curve a little more and get a mid-level that drag it way in just to see really what's there. Now look at that. You can see there's an awful lot of nebula in here. All right.
I never really noticed before. I've seen a lot of curved lines around M4, especially over the top, to the left side, and to the upper left. There's kind of a spiral line of stars there.
Oh yeah.
About 10 o'clock.
You mean here?
Yes.
Yeah.
Probably just chance alignment. Who knows?
Perhaps. All right, this is going to be called the Measure 4 or M4, and it's a GC, a globular cluster. Wayne says he is in Korea, heading back to Connecticut tonight. All right, Wayne. Well done.
Paul has another question for you.
Okay. Paul Martin. Paul, don't apologize for asking questions. Heck no, that's what I'm here for. This is supposed to be fun, and it's supposed to be educational and informative. So people can hang out, enjoy the music, and just hang with us. And if you want to ask a question, love it. And you're asking, have you tried the UHCS filter you're using against the L Pro? I haven't, actually. I'm using the UHCS by Bader, by the way, to answer your question. I have not used the I've not used the L Pro. I thought about it, but the UHCS has the band passes that I really want to see. And the L Pro, if I recall, it doesn't have the same exact band passes. I have a radiant filter too, which is very narrow band, all in one shot. And in something like that, this image would look really dark, but the nebulae would stand out. But it takes time for those to come in. It takes time for that to happen. So I'm not using it. It'll be fun to do narrow band imaging though with the 11-inch that we're gonna have in Benson, Arizona. Look at all this nebula that's showing up all of a sudden.
Yeah.
Let's go here because I'm wondering about this nebula here. Yeah, that's what I thought. Okay, we're seeing right now. We're seeing a little bit of the Alniyat nebula up there, and that's this stuff right here. Alniyat's way out of shot up above, but this is, see, we're getting to the busy part of the Milky Way now, guys, or the busy part of the galaxy, I should say. We are in the busy part of the universe right now.
Downtown.
We're in downtown, yeah. Downtown Milky Way. Thank you very much. Wayne, what are you doing in Korea? I'm assuming South Korea. Wayne went to Mauna Kea, and he brought me back this. It was very nice, you know. He didn't have to do it, but it was really nice of him. He brought me back this great T-shirt, which I absolutely love, and it has images of all the mirrors for all the telescopes on the mountain at Mauna Kea. Different mirrors for the 32.8 foot or meter telescope up there, 32.8 foot, yeah. And it's really, really beautiful, and so I really like that.
I have a water bottle from Mauna Kea.
That's right, you do. You told me that.
Yeah.
Who got that?
My,
your sister or something?
No, the plant manager or director of manufacturing, I guess he was.
Okay.
He married a Hawaiian girl, and he was over there, and they visited Mauna Kea, and he thought of me, so he bought me a water bottle.
That's nice. Let's move this down here and kind of bring it into perspective. Look at that. This is gorgeous red here. That's really something.
Yeah, the other globular kind of gives it a three-dimensionality too.
Yeah. Fantasy, hey man, thank you for putting up that link to the Mauna Kea meteor. Is that the meteor shower cam?
Live cam.
Yeah, okay. Cool. Alpha Centauri Virgo, what's going on? Nice to see you. Thanks for joining us. If you haven't, please do subscribe and hit the bell and give us the thumbs up. It really helps us with the algorithm. You've heard it all before. We're a growing channel. I mean, there's really nobody doing what we're doing here. We're teaching you astronomy, and you never know what you're going to get when you join, when you come in. So it's pretty cool. Right now we're looking at Messier 4. I will annotate this now. Since we got a number of images. We're going to... these are from the old annotation. Annotation just means, you know, label it. So you'll see these will be labeled. Okay, there we go. All right, so this is labeled, and measure 4 is right here. Okay, 6144 is right there. Yeah, that's something else. Nice, nice, nice. So those are the two primary things we have in this image are 6144 and measure 4, which is also 6121. NGC stands for New General Catalog. It's one of the many catalogs. We've got an index catalog. We have a Vandenberg catalog. Okay, we have Lin's Dark Nebulae, Lin's Bright Nebulae. We have Melamed catalogs. There's a giant number of catalogs. In fact, I can show you, if we go here briefly, I can show you kind of what we're talking about for catalogs. So, for instance, Caldwell catalogs, Measure catalogs, NGC catalog, IC catalog is the index catalog. That's nebulae and clusters. Barnard's catalog, and this is for dark nebulae. All right. Sharpless catalog, that's another one that shows these ionized hydrogen gas regions like these red ones you see here. Vandenberg, another one. The Vandenberg catalog is another popular one. It's got reflection nebulae. This one here is southern Milky Way, and so we don't use it. This is Lin's Bright Nebulae, and this is Lin's Dark Nebulae. And we have this one here, which is the galactic cluster, the Colander cluster. It goes on and on, but look at all these catalogs. So there's an awful lot of catalogs. And in the summer, if we have catalog like C selected, you're going to see tons of them, as you'll see. I'll leave it selected for now. And if we back out, you'll start to see many selections as we move down into Sagittarius and so forth. So we'll see them. Okay. So let's save this annotation. We'll save the image with the annotation. Okay, we'll get out of this because we don't need that. Right, we have 27 shots here. That's good enough for this. Okay. I'll let this next one come in, make it an even number. So with 28, we'll save it. Okay, we'll save this again. And save it exactly as seen. Yes, we're heading into downtown Milky Way. Alright. Okay. So let's do our low light shot here, a low light view. We'll go into deep sky again soon. Look how little you see when you're just looking at it normally, right? Okay. And now let's go up to Alniyat right here. So the comet's in Leo now, right? You said?
Yeah, it just moved from Virgo into Leo.
Okay, so it's still up high enough for us to see right now, I think.
If you like.
Let's find out. I'm going to look at Alniyat first. Oh, maybe not. Uh-oh. That's actually pretty low right now. Yeah, we'll probably have to do that tomorrow or something if we're going to do a stream. Okay, no problem.
What, it's Comet?
Yeah.
Oh, well.
That's alright. There's Alniyat. Okay, so what I'm going to do is I'm going to move us a little to the west.
Time marches on.
It does indeed.
I must be having fun because time sure is flying by.
I know. I know it's 1:30 a.m. here. Cosmic Ray is also mentioning the Gaia catalogs, star catalogs. That's correct. Yeah. Thank you for putting up the links, by the way, to the server.
Sure.
Let's see here.
Izabela, are you still with us? I haven't seen much of you tonight.
She was lurking. I think she's out there.
No, she said hi when she came in.
Yeah. Okay, this is where we're going to stop with the movement. And now I can see the nebula right here. You're going to like this one, guys. This is really something. Okay. Well, first of all, it was on the wrong setting. And this is the right setting.
There she is.
There she is. I told you lurking. See? Haha.
So she's snoring.
That's part of it. Yeah. I don't know why she'd be snoring. It's daytime for her.
8:32 in the morning there.
Yeah. All right, so we're going to do a 25-second shot of this.
I believe.
And we're going to come out of our low light mode and go into deep sky mode. And that's our beautiful previous image, which is up on the server right now. We'll clear this. No, yeah, Saturday morning, she says, best time for late sleep. You're right. Okay, watch this. This will be the first image of the Alniyat Nebula. All right, look at that. So this is the nebula around Alniyat. This is interesting because this nebula girdles Alniyat, and it's actually an emission nebula that is powered by Alniyat. And if we go into here and look at Alniyat, its spectral type is a O9 star and B7. It looks like it's a pulsating variable star, and it's a double star. So it's made up of an O9 star, which is again among the hottest stars in the universe, of the O-type stars, and it's also got a B7 in there as well. Let's color correct here and get rid of that incorrect haze. There we go. So this is what you see, and remember, these are only ever just points of light, just points of light, you know. But they're so bright that they can be seen from a long way away. It's hard to impress upon people how bright stars really are. Yep. All right. Look at that beautiful ring of gas around the star. So what's happening is there's neutral hydrogen gas out there in space as well. It's the most prominent and plentiful element in the universe is hydrogen gas. And so what happens is that's a proton with an electron going around it. And when you have a hot star like an O star, they have much of their energies given off in the ultraviolet, which is a highly energetic radiation that will affect atoms greatly and cause them to ionize. Their electrons jump up to higher levels and sometimes off the atom briefly. And that's what's happening here. And when the electrons come back into the atom, as they come back in, they give off a color. And in the case of the hydrogen atom, the hydrogen element, that color is red. And we call it hydrogen alpha, or H2, Roman numeral 2. And that's what we're seeing here. we're seeing this cloud of gas close enough to this star that it's being ionized. And it's light years from the star. It's light years. Hi, Donald Kunzer. Donald's with us. RJPX, what's up, man? Thanks for joining us. This is pretty. I mean, we're getting some really, really good imagery tonight. That's why I'm so excited. I was actually tired. I wasn't thinking I was going to stick around very long. But looking at the sky, oh, it's energizing. Everything's working well. It's guiding well. Let's see if we can squeeze out some more detail here. I'm going to add a mask, unsharp mask, pull out detail. Look at that. So now we have some detail in there. That's nice.
I don't see Donald Kunzer.
Yeah, he's up there. I'm looking right at him. He says, Ganymede and Titan. I'm late into the game. I'm late to the game.
Oh, there he is. He always says that.
He does?
Yes.
Oh, I never see that.
Well, the Ganymede and Titan thing.
Yeah. Well, this is very cool. We have 11 shots here. As you can see, the telescope sitting up there in the observatory right here. That's the live view into the telescope that we're looking at right here. This is the telescope computer. This is the telescope control. And so, I know I've shared this before, but you know, this whole block, this is telescope control, telescope computer, telescope view 1, telescope view number 2. The dumb guy who won't shut up, that's me. This is our stacking screen where we actually see that we've stacked multiple images. We've stacked 13 as of now. You can see right there. This is our camera and focus group over here. The most important values here are the exposure right there and the gain right here. The gain is how sensitive we make the sensor. And right now we're set to 250. It goes up to 300 or 400. And the advantage to that is you can see fainter objects. The disadvantage is the higher the gain, the higher the noise. And the noise is this modeling stuff you see in here. The exposure is how long we allow light to strike that now sensitive sensor. And so all this together brings you the SkyTour live stream experience. And of course, this is the main view. Let's see if I can pull that down and increase this a little bit. Yeah, that's pretty.
It is.
Yeah, it's just beautiful. Every time an image comes in, you see how it just sort of suddenly gets a tiny bit better. Donald Kunzer says he's not saying much. It's one of those days, right? We all get like that. Now that we've captured 17 of these, you can see this very subtle little ribbon in here, right here, which is very nice. Nels asks, what causes a large... Nels is asking what caused this ring. This is called a halo, and it's an artifact of our very, very fast photographic system. The telescope runs 25 times faster than it did natively. We've added a system that allows us to capture things much faster in seconds. So we're doing 25-second exposures, not 10-minute exposures. Because normally this would be like a 10-minute exposure, maybe longer. And we're doing it in 25 seconds.
Actually, you're seeing I don't know if you'd call it a ghost image or what, but that's the secondary glass on the front of the telescope.
This, you mean?
Yes.
Yeah.
And the two little dark bars are the cables for the camera.
That's right. Our camera is a little strange because if you notice in this image up here, if you're sure my cursor is, okay, there's a little tiny object in there, and that little tiny object, I'll see if I can point to it, right there, right at the end of the telescope there, that's actually the camera. It's in the front of the telescope. And so the cables go across the left and the right side, right? And this is a shield around the camera, and that is sitting on a lens system that replaces a mirror in this telescope. See, the way these telescopes work is that the light, and I'll just show you, the light goes down into the telescope, hits the primary mirror, okay, and then it bounces back up through, and I'm gonna just do this for a moment. Okay, there we are. All right, and the telescope we're talking about is like that one right back there. That's actually the East Coast telescope we've used for SkyTour livestream. This is my office on the ship. Okay, there's our portholes. And so what's happening is when the light comes down into the tube, it hits the primary mirror. All right, then it bounces up and hits a secondary mirror, and then comes back down through and goes through a hole in the primary mirror, and that's where it comes out at the back of the telescope. Typically, on this telescope, that's exactly what's going on. The light goes down into the back, okay, and then up to the front, and then down through the back again, down to the mirror, back up, and then down through. It's a folded optical path. If you stretched it out, the telescope would be much bigger. But what we're doing is we're actually using a different system. We actually have the light going down, hitting the main mirror, coming up, and not hitting another mirror, but hitting a lens system through which it comes out to a camera outside the front end of the telescope. Now that's pretty strange, but that's the system that allows us to run this telescope 25 times faster than it would normally run. I hope that was helpful. All right, so let's go over to our histogram and let's see if we can do a little processing. Pull out the darks a little more. Yeah, look at that. Now you can start to see multiple layers within the nebula. This is after 27 shots. Stacked images. The more you stack, the less the noise becomes a problem. And this is going to be our last object for tonight because Daryl's falling asleep and I'm pretty tired too. And Nell says the ring can be removed during processing. Yes, it can. And we do. For our Patreon subscribers, what we do is we provide the finished processed images. And these are images that can be blown up, and you can, if you want to buy photos and prints, you can go to our website at skytourlive.org, and it'll take you to our darkroom, and there you can get images printed on metal, printed on canvas, printed on and framed under glass. I mean, there's many different many different options for you. Okay, I'm going to go to 30 on this. There it is, and then I'll hit save. After I change the name, this is Alniyat. Alniyat. And we'll save it. So all these images will be available, and everything we took pictures of are already up on our server. And then what Izabela does is she will routinely update the application so that in all likelihood the next time you use this application, say tomorrow or the day after, these observations will now be in the app. So it's pretty cool. Nell says, do all telescopes have a camera on the front? Have this ring? No, not necessarily. But this telescope has been is an F10 telescope.
I thought it was an F8.
Yeah, I think it was actually. When I looked it up, I thought it was an F10. But it might be an F8. I might be confusing it with the Celestron 11. Sorry. So if this telescope is an F8, we've reduced our telescope's f ratio to f1.2, and f1.2 means it's very fast photographically, and when you have a very fast scope, you can get some very big halos like this. Only the brightest stars create them. Secondarily bright stars will also create them, but we can get rid of those. Okay, we'll save this one more time. And as always, I'll do a redo of, that's not the right data. I'm doing the annotation again. So what the telescope's doing now is it's finding where it's looking in the sky. It knows where it is, so it makes it quick, as you can see. And then it proceeds to name the objects that it sees. And we'll save this image with the annotations. Cool. All right. So we save the image with annotations and we're good. And then I'll save it one last time. Okay. Well, there you go, folks. I hope you had a good time exploring some of the pre-summer amazements that are out there and phenomena that are out there in the universe. We looked at the primarily in the constellation of Scorpius tonight. We did venture up to look at Messier 13 in the constellation of Hercules for a bit. Daryl told you what the keystone of Hercules, where the terminology comes from, and then we started to explore where we're going to go up the Milky Way as time moves on here, and we'll be seeing quite a lot of it. I think Cygnus is pretty high right now. Actually, I can't do anything with Cygnus right now. So I apologize, Ray. Ray wants.
Oh, shucks.
Ray wants Cygnus. Yeah, we could. Yeah, we could. Well, let's see. Hold on. Yeah, we could look at something up there right now, but I'm not going to do it. All right. We'll get plenty of time to do that as summer approaches. Okay, folks, I want to thank you for joining us tonight. And on behalf of Daryl and all of us here at SkyTour Livestream, I want to thank you for joining us. And we will see you on the next clear night. Hope you guys had a good time. Let us know. Do put a comment. Comment on our videos if you will. Give us a
That
thumbs up.
too.
Yeah, thumbs up is great. Yeah. RJP says, in your hammerhead of the Scorpion, I was having a look at it the other night. Atlanta metro skies are pretty bad now, but your first magnitude areas show up. Oh, cool. Thank you, Paul Martin. And you're welcome, Fantasy. Thank you, guys. All right. Well, you guys have a good night. And Daryl and I will catch you the next time the stars are out.
Good night, everybody.
Good night, folks. We'll talk to you soon. Okay. And you can enjoy this nice end video for the night.